Hello everybody, this is Bassam Kardali for CG Cookie, and here's a quick tutorial about doing Python for the first time inside of Blender. So if you're new to Python, this tutorial is for you. So an easy way to kind of explore what we can do with Python in Blender is pop open a Python console. And this is basically an interactive console that lets you type out Python expressions and just sort of see what happens right away. And it has a little prompt here. And so an easy kind of and useful thing you can do with it is use it as a little calculator. You can just type in like a bunch of math and very quickly see the result. So if you're like working in Blender and you feel like reaching for a calculator, just reach for the Python console right inside of Blender and you're good. And so that's sort of a very preliminary use of it. But it already tells us some things that are kind of interesting. So for instance, looking at this, it looks like we multiplied the 5 by the 10 first and then added the 100 to it. Let's see if I reverse the order if the same thing happens, right? So let's do 100 plus 10 times 5, and it did. The reason is, even though we're evaluating from left to right, multiplication always takes precedence over addition. So that's something to note if you're doing this kind of calculator stuff here. The star, by the way, means multiply, the asterisk. But you can use parentheses to kind of control that order. So if you want the addition to happen first, you have to actually wrap it in a parentheses like this. And the spaces don't matter, they're just there for prettiness. So just do that. And now I'm adding 110, getting 110 and multiplying it by 5. So parentheses are kind of always saying evaluate what's inside the parentheses first, and it's a very easy rule of thumb to say when in doubt use parentheses because they kind of control the order of execution. Notice that our numbers here don't have decimal points, they're just integer numbers, and indeed we can use a handy thing. We can type and then let's say put that 550 inside the parens. And so this is telling us what type this number 550 is. So this is our first function that we're calling, and it's also a function that's handy because it tells us about stuff in Python. So this is saying that the 550 is of type int. And that's how you call a function, by the way, in general. You type out the function name, followed by a parentheses, and inside that parentheses, you can put in some argument, basically something that you're going to pass to the function that it will work with. Some functions don't need arguments and some functions do. So if 550 is an int, if you put 550.0 for instance, that's a floating point, a float or a floating point number, basically a number that has a decimal in it somewhere. For instance, all these values in Blender like the location and scale and rotation are floating point numbers. So let's, addition, subtraction, and multiplication have utility, but of course we can do a lot more than that. For instance, we can take the sign of a number, so we can say sine of 10 and it will give us some kind of value, which is actually the sine of that. If you remember from your trig classes, that's also a function. And by the way, Python doesn't initially have a sine function, so where is this coming from? Well, what it comes from is from this import over here. So if you scroll up a little bit, This is actually very useful. It's just telling you a bunch of useful information, like the hotkeys that you can use in the console, for instance. And it's also telling you what kind of extra modules are kind of available to you. And I'm going to skip over this for a second and go down here. And so this from math import star is actually what's giving you the sign. So the sign function is part of this math library or module. And there's also like cosine and tangent and various log and various, fun math functions that you can use. What it doesn't have is a random function. So if I type out random and just try to get a random number like that, I just get an error. But I can copy the same syntax from math import star because there happens to be a random library. So I can do from random import star, and now I do have a random number generator, which generates a number from 0 to 1. So that is pretty cool. What's not cool is that, if I have to, get back to a calculation, I would have to scroll up or type it out again. And generally what we want to do when we're writing programs or scripts, when we do an expression like that, when we do add numbers or whatever, we probably want to store the result in a variable. We want to store that result so we can get back at it later. And the way we do that is with variable assignment. So we're going to basically use this assignment notation, which says evaluate the expression on the right and then store that result in a variable on the left of the equal sign, or the assignment operator. So for instance, I can type a equals 2 to the power of 8. And now you notice I didn't get a number back, but if I type out a, I get the number 256. And I can use a in other expressions. So I can say a plus 10, for instance, and get back 266, and so on and so forth. And I can even take that result and store it in another variable, so I can say b equals a plus 10, and now I have a b which has that number, which is useful. And another neat thing that I could do is I can actually store the result in the same variable. So this is maybe counterintuitive. I can say something like a equals a plus 10. And what happens now is that a is 266. So what happened here? Well, the old value of a, remember that this is a value, the a plus 10 gets evaluated before the equals. So the old value of a, 256, gets added to 10, and that becomes a number, and that result is stored back in a again. And so there's no contradiction here. And this is kind of a useful feature. So you can even have a shorthand for it, and you can write a plus equal 10, and that's going to add yet another 10 to a, so it's going to be 276 now. Okay, so that's kind of interesting, right? But what about like doing the same type of thing, but doing it with this cube object? Let's say if I could take the height of the cube and increment it by 10 units. That would be something more fun, or maybe by a random number, right? So that would be more fun than just manipulating the number a, the variable a. Well, if you hover a mouse over the transform, you can see that this in Python is, in the first line, is object.location. And then more specifically, it's giving us which object, this BPY data objects.location. So let's have a look at what that means. And like getting the object location, and what's the dot, right? Well, if you think of me as a person, let's say Bassam, let's say I was in Python somewhere, and you wanted to get my hair color, and you wanted to write Bassam's hair color, you would write Bassam dot hair color, right? similarly, if you want the cube's location, you would, let's say this cube was stored in a variable cube, you would say cube dot location. So the dot is sort of a get attribute. It's saying get the attribute of the thing on the left that I'm naming on the right. So you could say object.location or .color and so on and so forth, right? And so the next problem is, how do we get the cube from our console over here? There's two major ways that we can get it. One is from the context, and one is getting it by name. And I'm going to show the context way first, and we'll see the other way later on. So scrolling up here and looking at these convenience variables, you see that you have C equal bpy.context and D equal bpy.data. And that's also showing up, the bpy.data and the .context are showing up in the built-in modules. Well, bpy means Blender Python. And so bpy.context means Blender Python's context, and bpy.data means Blender Python's data. So the data means all the data in the file. It's basically the stuff you see in the outliner, all the scenes and the objects and the meshes and the actions and all that kind of stuff. That's in data, and we're going to go over that later. What's in context is a little bit less obvious, but also really useful. So right now the cube is active, is it not? Yeah, it is. It's highlighted here. You can see it's selected here. So if we go to this bpy.context and say object right after that and hit enter, it's going to give us the cube. So basically what it's saying is this object thing is the thing that's currently active in the context. So if I select the camera here and I run that again, I'll get the camera instead of the cube, because now the camera is active. So that's a handy way of getting the currently selected object without having to type out the whole thing for getting the object. And so the second thing is to get its location. If you hover over the tooltip, you can see that it says dot location there. So let's do bpy.context.object and then dot location, and we'll hit enter. And you see you get a triplet. You get a vector with 0, 0, 0, right? And there's a handy thing, is you can put a dot after location and type out X, Y, or Z to get the different components of that location. So if I type in a Z here, I'm going to get the number 0. So now let's try using our plus equal operator, right? So we're going to increment the height, and let's say we're going to increment it by a random number like this. Bang. It's moved the cube up by a random number, and we can keep on doing that, and it'll keep on moving up by a random amount each time we press enter.